Singapore is leading a global effort to protect one of the world's most critical but largely invisible pieces of infrastructure: undersea telecommunications and energy cables. Now, at the Shangri-La Dialogue in May, Singapore joined 16 others to launch a voluntary framework which aims to boost cooperation on protecting the undersea infrastructure. It comes amid growing concerns over accidental damage and the potential sabotage of these networks. So, why are these cables so important? Well, more than 95% of the world's internet and international data traffic travels through fibre optic cables lying on the ocean floor. Every international video call, online bank transfer, cloud service, and cross-border business transaction is likely traveling through one of hundreds of submarine cables. They stretch more than 1.4 million kilometers around the globe. Satellites carry only a tiny fraction of the world's communications, as they simply can't match the speed, capacity, and low latency of fibre optic cables. These cables are built and laid by specialist cable ships. Heavily armored and often buried beneath the seabed, they are protected from their biggest threats near coastlines, anchors, and fishing gear. But in the deep ocean, where such risks are minimal, the cables are much lighter and rest directly on the seafloor, thousands of meters below the surface. Maintaining them is still a surprisingly hands-on operation. When a cable is damaged, a repair ship heads to the location, lowers a grapnel or giant grappling hook to the seabed, and hauls the cable back to the surface. Engineers splice in a replacement section before lowering the repaired cable back to the ocean floor. The basic repair process has changed little over the past century, despite the sophisticated technology inside the cables. And for more, we have a guest who physically went to find out what undersea cable work entails. Jane Ruffino is doctoral researcher from Sodertorn University, and she joins us from Stockholm. Thank you so much, Jane, for joining me this afternoon. Well, let's look at this. So most of us think of the internet, we think of it as something in the cloud. But your article, it reminds us that it's actually sitting on the seabed. So what surprised you the most while doing this report?
I think the thing that always surprises me in my research is how much human labor, human knowledge, and human relationships are at the heart of everything that we depend on in terms of our infrastructures, whether that is submarine infrastructure, terrestrial infrastructure. All of it is extremely human. So I think moving beyond the growing awareness, which I'm very happy about, that all of the things that we depend on also have a physical material element, moving beyond that to the people who look after that physical element.
Did it change how you think about the internet every time you send a message or stream a video?
I mean, I think that came at the start of my research, was really trying to understand what are the physical things that our data depends on? Like, where does it live? Where does it go? Yes, it did. And I hope that with my work, what I really want to do is draw attention to the physicality so that we can maybe make better decisions for our infrastructures and build better things on top of them.
All right, speaking of better decisions here, one of the most interesting part of your story is that these cables, they don't simply become underwater junk. How exactly are they recovered?
So what was really interesting to me was finding out that these cables can be recycled. And so the report that I did was about lifting a cable off of the seabed and sending it off for recycling, where the materials can be put back into the supply chain. And that is not something that automatically happens. For a long time, they did just leave them there. Once a cable is on the seabed, it doesn't really have much of an impact on the seabed or ecosystem around it. So going to visit this ship, so I didn't get to go out on the ship because the ship goes out for 2.5 months at a time, and just meeting the crew and hearing about the operation of picking up this cable off the seabed. And what they have to do is very similar to a repair operation in the sense of that you you sail out to where the cable is, you lift it off the seabed with a grapnel, and but in this case, they pull it up onto the ship. And as you saw in those videos and photos, they spool it in these cable drums, and then they offload it on the pier when they get into port, and it's sent off to be split into pieces. There's mostly the largest amount of material is copper and polyethylene, steel and polyethylene, and then there's also copper. So the only part of the cable that can't be recycled is actually the fibers inside. And you can also reuse cables. So some cables that have been decommissioned for telecommunications use, they are used for scientific purposes. And there's also a growing movement to investigate, at least with some of the shorter distance cables, whether you can reuse some of these shorter cables, not the repeated systems like you're seeing here with TAT8, which was the cable that I went to investigate. But with some of these shorter systems, can you reuse them as like backup systems?
Right. So is recovering these old cables, are they mainly about sustainability, or is it today becoming economically worthwhile? How much real value is there in these materials?
So it's a little bit about sustainability. It's a little bit, but you wouldn't be able to do it if it wasn't good business. So when TAT8, which was the first fiber optic, transoceanic fiber optic cable, when this was decommissioned, there was originally a plan to recover it, 20 something years ago, but it wasn't economical to do this. And there wasn't necessarily the push to recycle at scale the way we see now. So it would only be doable if it was economically viable. There's about 3 companies that are picking them up, and there's a few advantages. So one is it's economically viable to recycle a lot of these cables. And another is that the seabed is actually very crowded. The seabed is a busy place. The places where there's actually a suitable cable corridor are already quite busy. So lifting up these cables creates space for new cables, and new cables are needed. And the kind of number of undersea cables is expanding pretty quickly internationally. So it's multiple reasons.
Let's look at the start of your report. You mentioned sharks. You led with that. So we often hear stories about sharks biting cables, but you actually debunked this myth. So what really poses the biggest threat to these cables then?
Yeah, it is not sharks. And, I like to remind people that the sharks were there first. So let's go easy on our marine ecosystems. But the biggest threat to cables, this is my I'm an academic answer, which is it depends. And one of the biggest risks is the number of cables. Having more cables, not having enough cables is a problem. But most damage to cables, as you kind of showed in the report before I came on, most of it's accidental damage. You go out there, you repair it, you splice a new section onto the cable, and you go on your way. So mostly it is anchors, fishing trawls, almost always accidental, and sometimes natural disasters, as we saw in 2022 off the coast of Tonga. So those are the threats. But whether the damage actually has an impact on your connectivity, it depends a lot on the number of cables that serve where you live and what happens to those cables once they come on shore. So one of the things that I think is becoming more difficult to debunk is this kind of stat that I think we all use very easily, this 95 to 99% of all international traffic. And it's 95 to 99% of what? And the 100% number represents all international traffic. So for most of us living in places that are well served by submarine cables, most of what happens for us happens on the terrestrial level. So I think that's probably the next thing to debunk is to add some nuance to if a cable is damaged, all of a sudden your internet goes down. And in most of the world, that is not the case. Where it is the case, they need more resilience. They need more cable redundancy. They need more terrestrial resilience.
All right. Well, you mentioned that the sharks came first. So question then now is laying thousands of kilometers of cable, across the seabed. It sounds like it could actually disturb marine ecosystems. So how do companies minimize this environmental impact?
Well, I mean, again, the regulatory environment is different depending on where you are, but in the whole world, there are always some form of environmental impact statement, and you do need to go through all of those steps. And the industry does take an active view of trying to be quite responsible, and I think that is one of the things that has surprised me the most in working with this industry is how genuinely interested they are in being responsible. And it's also probably not so much of a surprise because a lot of the people in this industry, especially in senior roles, started at sea themselves. So when you've spent time at sea, you start to care about the sea. So they do actually, so they go through very detailed route surveys, route planning. They, have to liaise with lots of government departments and professional bodies, and there are all kinds of scientific and regulatory requirements that you need to meet in order to lay a cable. And once a cable is down there, the main impact is if a cable needs to be buried under the seabed, there is an impact on the seabed when you do that trenching work. But if you don't, you're just dropping something that's a relatively inert object onto the seabed, and it doesn't actually have that much of an impact environmentally.
All right. Thank you so much, Jane, for speaking to us.
So you could leave them there.
Thank you so much, Jane, for speaking to us this afternoon. I've been speaking with Jane Ruffino, doctoral researcher from Sodertorn University.